Today we learned about vertex form of an equation. And vertex form is really fantastic because it gives us the vertex. So remember, our vertex isn't a point, it's always an x value and a y value. But in this case, instead of x and y, we're actually going to use what are called h and k, because h and k is what's in the formula. So whatever number is added out here on the end, our k value, that value is the same as our y value of our vertex. They're the same number. And the same is true, almost true at least, with the value that's here in the parentheses. This x value is going to be the same here. However, you need to remember it's going to switch signs. So these signs are always opposite. So they are always opposite signs. That's the important thing to remember there. They're always opposite signs. And lastly, don't forget that the number in front, our coefficient here, this a value, a is going to determine our vertical, because it's outside the parentheses, stretches, or compressions. Going to determine if the graph is going to stretch or compress. Remember, it stretches if a is greater than 1, and it compresses if a is between 0 and 1. So I have the equation y equals 3 times x minus 4 plus 1. So first of all, let's identify our vertex. Our vertex is going to come from our 2 points, our negative 4, and from our positive 1. So the x value comes from the negative 4 because it's what's in the parentheses with x, so that's our x value. So that tells us that our vertex is going to be positive 4 because it switches signs, and then positive 1. So notice these numbers, the 1s are the same, and then the 4 is going to switch signs. So then if we have to find our axis of symmetry, we're just going to write AOS, it's going to be x equals, it is the exact same number as what we've been using. So it's going to be x equals 4 because that was our x value for the vertex. It's going to be the x value of the vertex. So it's the same value that we used up here and we got from our equation. So here's another problem for you. We have negative 1/2 times x plus 2 minus 4. So first of all, we want to identify our vertex. So remember, our vertex is going to come from the ordered pair that's already in the problem. So the positive 2 is going to become negative 2, and the negative 4 is going to stay the same. So my vertex is negative 2, negative 4. To find my axis of symmetry, it's going to be x equals negative 2 because it's the same number. So every time, what number's in the parentheses with x is going to be your x value with the opposite sign, and it is your axis of symmetry. And the number that's outside the parentheses, the minus 4, is going to be the y value of our vertex. So remember, what this means is that because we have a plus 2 inside the parentheses, this plus 2 inside the parentheses tells us that our graph shifted left 2. Our graph shifted left 2. The reason it shifted left 2 is because it's inside, so that makes it horizontal, and it's the opposite, so instead of being positive, it's going to be left 2, and it's not going to be right 2, it's going to be left 2. And then the minus 4 on the outside is going to tell us that our graph is going to shift down 4. The outside part is going to be completely normal. It's not going to be any different than what it should be. Lastly, we have to graph y equals 2 times x minus 3 plus 1. Well, first of all, we know a couple things. We know our vertex. Our vertex is going to be the ordered pair positive 3, positive 1. So I'm going to graph that point first. So positive 3, so I'm going to go right 1, 2, 3. Positive 1, I'm going to put a point there. That's my vertex. So my vertex is done. I also know now what my axis of symmetry is. So my axis of symmetry, which I'm going to call my AOS, is going to be the equation x equals 3. Remember, that's going to be a vertical line that's going to go through the vertex. So that's our... To find other points on our graph, we're going to want to look at our table. So just to help you guys out, there's a couple values I'm going to go ahead and put in here. So one of our values that's going to be in our table is the ordered pair positive 1, 9. There's going to be the ordered pair 2, 3. We already have our vertex of 3, 1, and then there will be 3, 3, or 4, 3, I'm sorry, 4, 3, and lastly, there will be 5, 9. So I can go ahead and graph these points. Remember, we can use our table to get those points. And the first of those, so positive 1, positive 9 is going to be here. 2, 3 is going to be here. And then it's easy to figure out where the rest of them are because my axis of symmetry splits the graph in half, so the left side is identical to the right side. So this is what my parabola ends up looking like. Notice my sketch isn't perfect, but yours doesn't have to be either.